Everybody, another day. Feels like I keep saying that as my introduction. So I'll eventually need to come up with a little greeting for each one of these videos. Yeah, so let's just cut to chase and continue on with our sea adventure. So again, it's best that I realize that I should probably encourage everyone to download or yeah, download this PDF, but not only just download the PDF, but also purchase this book. I'm going to most likely purchase a copy myself. I thought I had a copy, but I was looking through my bookshelf just last night, and it turns out that I actually don't have it. So I'm going to encourage everyone to buy the book because I will too. Anyway, continuing off, we're working with strings, right? And here uh, we have this bit that discusses about why we actually have to consider an extra character when it comes to strings. So let's say we have a string S that is Shatner here, and really it's just an array of characters, like it says right here, right? But you really define a string or initialize a string to a variable in C this way usually. You could do it like this, but it's kind of weird. So usually by convention we stick to this. Ultimately, it'll just equivalently look like that, right? This array type of declaration, right? So each of the characters in the string is just like an element in an array, which is why you can refer to the individual characters in the string by using an index, like s at 0 and s at 1. So the example here shows us that s at 0 is capital S, and then s at 1 is capital H. Now here's an important point. Don't fall off the end of the string. So what happens when C wants to read the contents of a string? Say it wants to print it out. Now, in a lot of languages, the computer keeps pretty close track of the size of an array, but C is more low level than most languages and can always work out exactly how long an array is, or can't always work out exactly how long an array is. So can't is very important. So C doesn't know, right? We had to be explicit in the amount of elements that we have in an array, or if it's a string, we always have to pass in the null terminating character here. So C is going to display a string on the screen. It needs to know when it gets to the end of the character array. And it does this by adding a sentinel character. Okay, so the book is calling this null terminating character as a sentinel character, but we're using it interchangeably. I'll try my best to say sentinel, but you'll probably always hear me say null. Yeah, the null character. See, C coders often call this the null character, right? So the sentinel character is an additional character at the end of the string that has a value of this character, like we have seen. Whenever the computer needs to read the contents of the string, it goes through the elements of the character array one at a time until it reaches a null terminating character. This means that the computer sees this. It really just sees Shatner. But really underneath the hood inside memory, right, there's like a block of memory allocated for the string, and each address in memory, right, pretend these are addresses in memory, right, hold a character. At some point, at what to signify the end of the string, we have a null terminating character. Okay, and when we declare a string like this in C, it's automatic that we'll have this at the end, right? C is smart enough to actually add that at the end. Okay, so we're not really adding something like this. For example, let me just start a new project. We'll call it string test, and we'll say we'll have a file called main.c. So we're not doing things like this, right? Where it's like Shatner this, right? Where it's more like this with Shatner, and then C is automatically going to insert that. So really, it looks like we have 7 characters in the array or 7 elements in the array, but it's more like 8. So yeah, so it's giving context of why they had to define, their array with 3 elements instead. Okay, so let's skip this and let's actually do an example with strings. Let's just play around, right? So given that, we'll actually, okay. So we'll write a simple C program and we'll kind of just start seeing behavior, okay? So let's mess around with strings. All right. So first thing we do is we include our favorite stdio.h. And, in our early C programs, we're going to have to just include this specific library often, right? So it's kind of going to be ingrained into muscle memory eventually. Is this big enough to see? I sure hope so. Okay. Maybe now I'm just getting insecure because I had shrunk it yesterday. Now I kind of want to bring it back up to a good size again. I'll bring it back up to 22. Okay. So now we'll include that and then we'll define our main function again, right? And we'll just declare a string, right? It'll be char s and it's an array, or maybe it's like this, right? I think it's actually more like this. Go check. Okay, and we're actually going to first print out the string, so just for sanity. And our function that we use to print things out is going to be printf. Okay, that's like the standard, print function that we use in C, and it's usually like the F stands for formatted. So whenever we want to print a string, we'll have like a placeholder, right? In this case, it'll be %s, which I had mentioned yesterday, and then you give basically the value you want to replace it with. So in this case, it'll be the string s. Okay, and we want to insert a new line at the end. Okay, at the end of that, we'll return 0 because that signifies that we have a program that had run successfully. So let's actually figure out where we're at right now, and let's actually change directory into our new project. I think it's called string test, and we'll just compile it, right? And let me show you something. So we'll compile the program main.c in our directory here, but instead of a.out to be our default output program, let's actually be more creative and name our program string test, right? So how do we specify a custom name? We'll use gcc main.c, which is our input file, and then we'll do a -o, specify an output file. So our output is going to be called string test. Okay, so we'll compile that, and if we list our directory again, we'll have this new executable called string test. And before it was a.out, right? So to execute this program, we'll just like normal, and we'll have Shatner, right? So we've just simply printed out a string, right? And this is how we declare a string in C. It's this char s, and then we have to say it's a character array, right? The reason why we don't have to specify any sizes in this array is because we've already specified the string, right, explicitly. So C can figure it out. It can figure out the length and things because it does have to insert that magical, right, null terminating character at the end, right? So it knows the size. That's why you don't have to specify the size of this array. More on that later. But let's just play around a little bit. Okay, so like before, let's actually print a character one by one, right? So we can do printf, right? And instead of doing %s this time, we'll do %c to say that we are printing a character type. And we'll print a new line, right? And instead of passing the entire string, we'll actually only print out the first letter. Okay? And then let's, for fun, print out the last letter. Or not the last letter, the next letter. I'm spoiling it. Okay. Now, we've made changes to our program, right? So that means we have to recompile it if we want to see it working. We can't just do this again, right? We can't just execute the program again because this C is not a dynamically like it's not an interpreted language, so it just can't read the source code. You have to compile it. So we'll just compile the program again, and then now we're running. So now we see that we have not only we printed the string with Shatner right here with line 6, we've also printed out the first character and the character after the first character, second character, right? Because arrays are zero index based. If you're coming from any other languages like Python, JavaScript, that's pretty much the same way, right? Okay, cool, right? Let's take a look at the last character. So in this case, it's going to be 0, 1, 2, 3, 4, 5, 6, right? Index 6, okay? So let's print out index 6. That's the character stored at index 6. And as expected, we should get R. So let's recompile and run our program again. So we'll have R, right? Pretty interesting. Now I'm going to do something that makes it easier to kind of visualize this. I'm going to wrap each character with a square bracket so that we can actually see something interesting, okay? So let's do this. Let's wrap every character with a square bracket and see what happens. Okay, now we'll recompile and we'll run the program again. It's not too exciting, but it does change the way we see things, right? We'll see that, we expect, like, a character to be between these square brackets, okay? Now, again, I did mention, and the book said this too, that there's always an extra character after the string. That's why the length of this array, this character array, is always one more than the number of characters that we counted. So what happens when we actually print out the character after the last character, right? What does a null terminating character look like? We'll see. This is my first time actually doing this exercise, so. Okay, so we know that the last character is at index 6. What happens when we print out index 7, which is the null character? Because if we go back to the book here, we did see that SS7 is a null character. And the reason why we wrap this in brackets, right, is because we want to see what it actually looks like, right? So let's actually do this, where we print out the very last character, like not the visible character, but the null terminating character. Interesting, right? It's not a printable character. So if we look at, let's say, the ASCII table, basically every character is, at least the beginning parts of, the lower level number characters, they are part of the ASCII type, right? The ASCII standard of characters. So we'll see that the characters here, right? The null character is 0, right? So that's why we escape 0. And it is not a printable character. That's why we have this here. It says null. And then I think most characters from 0 looks like all the way to 32nd character are all not really printable, right? They're either like some white space or some other designation, right? And then everything after that becomes a printable character, except for the last one here where it represents a deletion character. Yeah. Cool. Just important detail. Okay. So, what happens then if we actually modify a string, right? Can we modify strings in C? Yes, we can, right? So if we're able to tap into each individual character, we can technically modify it. Can we? So let's try it. So let's actually change the first character, right? S at 0. We want to point that, we want to assign that a different character. Currently it's this, right? So if I did this, and then I did printf percent percent s new line, and we'll print s. We should get the same thing technically, right? We've got the same thing here, Shatner. But what happens if I did this? Oops. What happens? Well, we're attempting to assign the character H to as the first letter of the string, right? So if we recompile, we see something very interesting, right? We see that we've replaced the first character with the capital H. Now we have Hatner. So we can modify strings this way. In other languages, strings are actually immutable, where you have to create a new copy, right? But here we can actually modify strings in place, and that's very powerful in a way in that, there's an efficiency thing going on here in that we can reuse strings and just assign just different values to those memory locations. That's very powerful if you're coming from Python or JavaScript. Something like this would require maybe like a string slicing and then like concatenating just to be able to do that, right? So I like this, right? But it's also very dangerous. Okay, it's very dangerous because looking at this, right, we're entirely dependent on our string ending with an alternating character for C to kind of process this, right? Technically, we're not really bound by index 7 as the last character of the string, right? Technically, these are just offsets in memory, where S at 0 is like the base address. If you imagine like memory being cubbyholes, right? S at 0 is just basically the first like address of that string. And every time we go through every element, it's just incrementing the address by some offset, right? In this case, for a character data type, we have 1 byte, right, per element. So basically, it's just like address 1, address 2, address 3, address 4, address 5, and so on. It could be address 1000, 1001, or 1300, 1301, 1302, and so on. Right? So, is that right? Yeah. Basically, they take up only like one space, right? So that doesn't stop us from actually going really out of bounds, right? So, for example, we could say S at 8, right? Or let's actually print what's at S at 8, right? So technically, going back to here, we're only expecting 0 to 7 because the string ends at 7. But what happens when we print whatever's at index 8? So let's just do here, let's just print this at index 8, right? Oops, print F. Okay, it compiled. Let's run it. We don't get anything, right? But what happens if we say index 81? We don't get anything too. How about index 891? Okay, looks like we can actually safely access things, or so we think, right? But what we're really actually doing is we're actually going out of bounds in memory to other places, right? It just so happens that there's nothing there, or there is something, it's just not visible, okay? So if we were to actually accidentally overwrite, for example, S at 7 away from our null terminating character and into like something like A, for example, we could have something very interesting that now let's try to actually print S now, right? We don't have a null terminating character anymore. So what happens? What happens? The string after replacing null character is okay. So we've gotten rid of the null terminating character where it really depended, like it was C really depends on this. When it's printing out the string, it's going to print character by character by character until it hits the null terminating character and it stops, right? So like what happens if we actually get rid of it? By assigning A to index 7, which is where the null terminating character was at, right? So now we don't have that. We have like Shatnera, or in this case, Hatnera. So let's compile and run it again, right? Okay, that looks pretty good, right? So nothing's stopping from doing this, us from doing this. It just so happens now that the next index was actually a null terminating character, or at least some sort of null, right? Let's see what else. Yeah, so we can also shorten the character too. So, let's say we didn't like it being 7 characters long. Let's say we want it to be 3 characters long, right? So we could just say S at 4 is itself a null terminating character. What happens then? All right, so I've assigned index 4 to be a null character. That means only the first 3 elements in this case, right? If you go back to here, this is now /0. That means, or not the first 4 elements. Sorry, will be chat. Sorry, that was unintentional. But I expect only these 4 to be displayed, right? So let's see. That's close, right? Because we replaced the S with H, right? But that's what we expected. We only expected 4 characters to appear. So that looks about right, right? So what was the point of all this? I think I just wanted to show you how like flexible uh C strings are, right? Like um, they're just character arrays, so you can operate with them like as if they were an array of characters, right? You can assign them, replace them. You can even like assign null terminating characters to shorten them, and you do a lot of interesting things, right? You can completely wreck the string by erasing the contents by just setting the base character, the first character, to a null terminating character. So now nothing is printing. Is it the best way to do it? Probably not, right? I don't know. Like I'm still learning too. So yeah, that's strings for you. The rest of here is just like saying, this is a function call. This is not a function call. So let's see. I encourage. Hey, let's do this. No dumb questions. Okay. Is there anything useful? Okay, let's do. There are no dumb questions. So why are the characters numbered from 0? Why not 1? So again, that's because of the indexing, right? The index is an offset. It's a measure of how far the character is from the first character. So going back to what we were saying about memory, right? Why? The computer will store the characters in consecutive bytes of memory. It can use the index to calculate the location of the character. If it knows that C at 0 is at memory location 1 million, then you can quickly calculate that C at 96 is at 1 million plus 96. And that goes back to saying, like, to knowing that a character is only 1 byte, right? So it's only 8 bits of in address, right? So that's why there's 96 locations, right? So why does it need a sentinel character? Doesn't it know how long the string is? Usually it doesn't. C is not very good at keeping track of how long arrays are. And a string is just an array of characters. So remember, in C, we have to know the length of an array, right? Even when we're like dynamically creating arrays, we have to know the ultimate size. There's like some size that we have to know, especially if we're iterating through, we have to know when to stop. It's not magic, right? So it doesn't know how long arrays are? No. Sometimes the compilers can work out the length of an array by analyzing the code. But usually C relies on you, me, the developer, to keep track of the array. So does it matter if I use single quotes or double quotes? Yes. So single quotes tell us that something's a character, meaning that we only have one character, right? When we use single quotes, we only use one character, versus double quotes are an array of characters, right? A string. So should I define my strings using double quotes or as an explicit array of characters? So going back to this, should we define a string that looks like this, or should we always define a string that looks like this, right? So let's see what they say. Usually you have to define, or usually you will define strings using quotes. They are called string literals, and they are easier to type. So yeah, just go on ahead and define strings like this. Are there any differences between string literals and character arrays? Only one. String literals are constant. We'll talk about that later. What does that mean? Oh, I guess it means you can't change the individual characters once they are created. Really? I guess I showed you guys something different, but the way I did it is valid, right? What happens if I try? It depends on the compiler, but GCC will usually display a bus error. I don't know, it worked for us. A bus error? What the heck is a bus error? C will store string literals in memory in a different way. A bus error just means that your program can't update that piece of memory. Okay. Let's see. Okay. Yeah, so again, like this is probably just discussing what a function call looks like. So, we can actually create more functions than just the main function, right? And then there's if else's, right? So, an if statement kind of looks like just what you would normally be used to seeing in Python and JavaScript. So maybe let's make a program. Let's write another program. Yeah, let's do that. So let's do this. Let's first commit what we have, right? So I'm going to go one directory up, and I think I only have one directory, right? So I'm going to add everything in this current directory, which is going to be string test. And yeah, so there's only, ooh, I don't want to add the binary. Should I add the binary? Whatever. Fix that later. Okay, so let's make another program called let's do Caesarean cipher, and let's just skip this fluff here, right? And just go over what it's trying to say. I pre-read some of this actually. It's going through like if statement switches and things like that, right? So yeah, I don't think it's particularly interesting, but let's see. Okay, let's save this for later and let's write a new program. Okay, so let's create a fun project. Okay, so let's do Caesarean cipher or some like primitive form of it. And if you don't know what Caesarean cipher is, I think it's defined in Wikipedia. Caesarean cipher. It's like an old school way of encrypting things back in the day, right? Let's see here, where you kind of have like a character and you have some sort of shift, right? And you basically encode a text, right, based off of that shift number. So let's say if I say a shift of 2, like every A basically will become some sort of number, right? Um, so let's see, the cipher illustrator uses left shift 3, so left shift, right? I think it could be right shift too. Let's see, it doesn't really matter. So you just have to like kind of figure that out. So a left shift of 3 where E is here, so you go back 3 spots, right? So 1, 2, 3, right? So that's basically it. Like there's no hard rule to it. I think that's the reason why it's called encryption. It's up to the people to kind of decrypt that. So we're just gonna create very, 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 very basic formulas. Very basic. Not we don't. I don't really care about like the details, but basically our program is gonna do this, right? So I'm gonna write it down. Okay. So in pseudocode, right? Our program will first ask for a character from the user. So ask for input. Okay. Then take that character and shift by some amount, right? We'll take that character and shift some amount. Print the result. That's about it. Basic program. Okay. So we're gonna have to make use of a new function, right? So we have printf. Now we're gonna use scanf, right? And scanf, if we take a look at scanf, that will ask input from the user. And just looking at the Wikipedia, it just says it's a standard library function that reads and parses text from standard input, right? So it's as simple as, this is not a good idea. It's not a good example. Yeah, it's as simple as basically you declare some sort of string, you're going to ask for, right? In this case, like a word that has 20 characters or 21 total characters because it's a zero index, right? Where the last character is going to be a null terminating character, right? So you'll ask for scanf will take two arguments. One is going to be the placeholder, right? So it's asking for ask for 19 characters, and basically the array you want to store those characters into. It's going to store that into it's going to kind of point the input or point the array to that input, right? That from the user, and then I think it'll just print out the word here. So that's like a very simple example. And I think put s takes care of or maybe scanf takes care of the null terminating stuff. So um, let's see. Let's check. Yeah. Scan character string. The scan terminates at white space. A null character is stored at the end of the string, which means that the buffer supplied must be at least one character longer than the specified input length. Right? So scanf, if you're scanning a string, it'll automatically throw in a null terminating character at the end as long as your array that you're actually providing, which we call a buffer, has enough space for that. Okay. Oops. Yeah. That's about it. So real quick, just do our same thing. Include stdio.h, right? And we'll have our main function. Okay. And we'll just quickly return 0. Okay. And so again, we're going to ask for a character from the user. Sure. So let's do this. Let's have a message string that we're going to ask, right? So we'll do something like this. Message, character message, right? Is going to be please input a character or a letter. Let's just say letter from A to Z, lowercase. Okay, we'll have a new line here. Okay, and we're going to first ask. So we're going to print F. We're going to print the string out, right? And let's not have a new line. Let's do this. Yeah, let's have a new line. All right. So, what's going on? M is undefined. Why? Error message. Why? Oh, it's just my ID being my ID. Okay, so we'll print the message and then we'll ask for one letter, right? So we're gonna have a buffer, right? Basically something to hold our strings. And remember the spec of scanf, it says, going back to this, a null character is stored at the end of the string. So we need to make room for that. So we're gonna have a buffer of 2 characters, right? So we're gonna ask for, so we'll have buffer, or let's just say input. This will define our input and we'll have 2 characters. So length, it comes after the square brackets. So the reason why we didn't need one here is because we're gonna specify the string literally like this already, right? So um, that's why we didn't need to specify the length. But here it's like we don't specify anything, so we want to initialize an array with just 2 empty slots. So that's why we don't have anything assigned yet. So we'll use scanf, and then we'll ask for basically 1 character. Is that how it works? Let's see. Let's see the example. Yeah, something like this. Or can we just do C? Let's just do C, right? And then I think we'll just enter will also create the new line automatically. So we'll ask for input at 0. Okay? I think that's how it works. Okay. After that, let's define a shift. Let's define a shift, how many we're going to shift by. So we'll say 2 for now. So what we're going to do is we're going to say the result is going to be a character, right? Given the input at 0, 0, right? Actually, why do we need to do this? We can just say this. Let's just do this, right? Let's just do this. I think it has to be a pointer, but it's okay. I think it has to be like this. Never mind about that, but anyway. Okay, so we'll do input plus shift, right? And then let's just print out our result. Not sure this is going to work, but let's see. So we're going to ask for the input for a character, right? So we defined it. So we first print the message we want to ask for, the user for, and then we'll define a placeholder character where we want to actually then insert the user input using scanf, right? We want to take in 1 character, so that's why it says %C, and assign the the address at input, which is this ampersand here defines like address at input to point to the value that the user just inputted. Then based off of that, we're going to take the value that we found from the user, because characters are just numbers. We'll shift it by some amount by adding it, and it will just kind of cast that into a character called result, and we'll print it out. So let's see what happens. Syntax weird, but oops. We'll go to CD, Caesarian cipher. Then we'll GCC main.c /o. We'll see cipher. Okay. We'll output that as a cipher. So let's do that. Then we'll execute. Okay. So far so good. Okay. Let's say if I say T, I get V. Awesome. So we actually have something working. Let me respond to a text. Oh. Okay. So let's try another one. A. We'll get C. Cool. So let's change our shift to 5. Okay. And we'll recompile because, non-interpreted language. C is not interpreted. We'll go again. If I did Q, what would I get? V. P Q R S T U V. Yeah, that's right. Yeah, let's try something different, right? Let's test it again. Let's do Z. What do we get? We get nothing. Let's try it again. Let's try star. Hmm. Is this what we want? Probably not. We did ask for something. We did ask from A to Z, but it's actually adding any character, right? That is coming from the user and shifting it by some amount, right? I don't think that's right. So let's actually adjust that with some conditionals. So I'll leave that as the next part of this video. So leave you to it. Play around, right? Especially play around with like strings and also like just seeing if this could be made better. Like maybe try to see if you can actually ask the message in one line with the input here, right? As opposed to putting it into two lines. Maybe that's a great way to like kind of consolidate a little bit and just play with like bad input and things like that. So yeah, so I'm gonna quit out of here and I'm gonna go back up one directory and I'm just gonna add. And I keep using git add dot, but that just means to add everything in the current directory. But I can also, since I know that I'm only interested in one directory, I'll just add the entire directory here, and that should add both. And again, I'll just add the binary, it doesn't matter. So yeah, I'll do git commit Caesarean cipher. It's not really, it's just a shift of characters, but okay. So yeah, that's it. So talk to you all tomorrow.